Good day. My name is KobusLouw. I was asked by the South African Bitumen Association, or SABITA, to do a presentation on the history of bitumen emulsions in South Africa. I joined the industry about 46 years ago. During my career, I was involved with the research and development of bituminous binders, especially bitumen emulsions. The three pioneers in the bitumen emulsion industry in South Africa are Colas, African Bitumen Emulsions, and Violet. In 1928, Colas established the first factory in Cape Town. 2 years later, Violet also established a second bitumen emulsion factory. In 1932, African Bitumen Emulsions built a factory in Durban. These companies all joined together through the years, and in the year 2000, Colas France bought the business from Colas South Africa. Another major player in the bitumen emulsion industry is TOSIS. TOSIS was established in 1974, and in the year 2013, they were taken over by a major road construction company. Other companies joined the emulsion industry in 1980 and onwards. Currently, there are 13 bitumen emulsion factories in South Africa. After the first three factories were erected in Cape Town and Durban, a number of other factories were soon erected in the rest of the country. At one stage, there were about 20 emulsion factories in South Africa. In the early days of emulsion manufacturing in South Africa, bitumen was imported in drums. The first crude oil refinery was only built in 1954 by Mobil in Durban. Shell and BP built a second refinery in Durban in 1962. This was followed by Caltex in Cape Town in 1966 and National Refineries, or NATREF, at Sasolburg near Johannesburg in 1971. Unfortunately, the first two refineries ceased operations in the last 3 years. The refinery in Cape Town has also not produced any bitumen in the last number of years. The only supplier of bitumen currently in South Africa is thus NATREF. The country is thus largely dependent on the importation of bitumen for its requirements. You can see here's a picture of an old emulsion factory. Notice the large number of bitumen drums on the left. It was quite an operation in those days to produce a batch of emulsion if your bitumen was supplied in drums. You first had to cut open the bitumen drums, invert it, and place it in steam ovens. Only after the bitumen had melted could you proceed with manufacture. A picture of one of the emulsion factories in Cape Town in the early 1950s. Notice Table Mountain in the background. The first emulsions produced were anionic spray grade, also called the RS type, based on long-chain fatty acids. These emulsions were mainly used for chip seal operations and for tack coats under hot mix asphalt. Unfortunately, they were slow breaking in behavior. The second grade that was produced was anionic premix grade, also called the MS grade, also based on long-chain fatty acids. These emulsions were used for preparation of cold, open-graded patching mixes, but unfortunately, they were also slow breaking in behavior. High-float emulsions were available, but demand was very limited, despite the enhanced rheological properties of the residual binder. Various attempts were made in the early days to produce SS type of emulsions, but with mixed success. A chip and spray operation taking place with the early anionic emulsions. Another old historical picture where RS emulsions being sprayed for chip and spray application. These early anionic emulsions were not without their problems. The main problem was that it was slow setting during lower temperature conditions. Also poor adhesion with difficult aggregates such as quartzites and granites, especially during prolonged wet conditions. Also, it was difficult to dilute these emulsions with hard water, especially for fog spray applications, as it would block the tanks and the nozzles. It was also difficult to clean or rinse the equipment with hard water, as it would cause lumps. And these emulsions, of course, couldn't mix with fine-graded materials. This is a typical example of what happens if hard water is mixed with these early anionic emulsions. The period 1956 to 1960 was indeed a landmark period for the emulsion industry, both here and abroad. Long-chain amines and diamines became available to the bitumen emulsion industry. It was now possible to produce CRS and CMS cationic emulsions, and that was the end of adhesion problems with difficult aggregates. Another breakthrough was the availability of a rosin-based anionic emulsifier from the USA that was suitable for producing SS type of emulsions. Emulsions prepared with this emulsifier could mix with fine-graded materials and even with Portland cement. This was indeed the birth of the slurry era. Slurry soon became very popular. The early contractors were very innovative in the mixing and placing of this new product. This contractor was a bit more sophisticated, and he added a concrete mixer on the back of the truck. Purpose-designed mix and lay slurry machines were soon designed overseas. This is one of the early young machines imported from the USA. There were a number of technologies that were made possible by the availability of the SS type of emulsion. These were slow set slurry overlays. On areas where traffic accommodation is not a major problem, this type of surfacing is still very popular. The Cape Seal application. The Cape Seal consists of a 20 mm single seal covered with two hand-applied slurry layers. This is a picture of the first layer of slurry being applied on the 20 mm single seal. In certain parts of our country, the ambient temperatures can at times rise to 40 degrees centigrade and more. Under these conditions, the mixing of slurry can become problematic. Sometimes premature breaking of the emulsion takes place in the concrete mixer, and then this phenomenon called balling occurs. It's quite an expensive occurrence. It was soon realized that bitumen emulsion could be used to upgrade substandard base course materials to a higher level of performance. In the absence of sophisticated equipment to execute this task, conventional construction equipment was used. In later years, purpose-designed cold in situ recycling equipment became available to execute this task. It has subsequently also become a very popular application in South Africa. Sabita has issued a technical guideline TG2, called Bitumen Stabilized Materials, that covers the construction and design of this type of materials. Bitumen emulsions are used in both open cast mines and underground for the suppression of dust. The process involves progressive enrichment of the upper 50 mm of the surface with bitumen emulsion. Natural rubber latex was probably the first modifier that was used to modify these early anionic emulsions. Anionic styrene butadiene rubber, or SBR latex, became available in the early 1960s, and it soon became the modifier of choice for the modification of anionic emulsions. Cationic SBR latex became freely available from the early 1990s, and a host of cationic latex modified emulsions were developed. It is still the most popular modifier for cationic emulsions in South Africa. Around about 1965, invert bitumen emulsion primes were introduced in the country. I suspect that it was a Shell development. As you can see in the picture, and on the left-hand side, an invert emulsion consists of water droplets dispersed in a cutback medium, and it's called a water in oil emulsion. On the right-hand side, it's the conventional oil and water emulsions that we all know. Now, these primes were very, very popular for many years, but it was subsequently replaced by other products. You can see the picture on the left. A water and oil emulsion is black in appearance, where an oil and water emulsion is brown in appearance. During 1977, the first CSS type of emulsions were manufactured in South Africa. These products were popular for approximately 10 years, but the demand for SS emulsions remained dominant. So the manufacture of CSS emulsions have now ceased completely, mainly due to cost implications. Also in 1982, a license agreement was reached between Petrocol and Rushik in Germany for the application of the Ralimac microsurfacing in South Africa. Ralimac's been very successful in South Africa, and Sabita awarded an award for excellence to Petrocol in the late 1980s for bringing this technology to South Africa. Other microsurfacing products have subsequently also entered the South African market. This is a picture of a microsurfacing unit brought in from Germany. A variation of the microsurfacing is rut filling, which plays a very important role in the maintenance of the South African road network. The year 2005 saw the introduction of cationic cutback bitumen emulsion prime. It is currently the most popular prime in South Africa. It is very popular because it has reduced open time, its excellent penetration of most base course types, and very important, it is non-flammable, it's therefore very safe to use, and it's economical, which is probably one of the main reasons why it is so popular. This type of prime has virtually replaced the use of flammable cutback primes completely. Here is a picture of the cutback emulsion prime being applied on a runway near Johannesburg. During the period 2010 to 2020, three important technologies were introduced into the country. First of all, the production of the first SBS modified bitumen emulsions occurred, and also the first trackless tack emulsions and bond coats were manufactured. Very important also was the availability of a double spray bar system to accelerate the breaking of polymer modified cationic emulsions. The current focus of the South African bitumen emulsion industry is the use of organosilanes in bitumen emulsion. This technology is not yet fully accepted. The benefits still need to be substantiated with field data. Trackless tack and bond coat emulsions, also a slow acceptance of this technology, but development is continuing. Under the auspices of Sabita, they're looking at the development of an emulsion performance grade specification. If you look at the South African road network, we've got various categories of road, but what's important, the total surface road network is about 156,000 kilometers, whereas the total gravel network is about 592,000 kilometers. What is important, that 78% of the roads that are surfaced are covered by seals. And in conclusion, South Africa has a vast road network, and bitumen emulsions have historically played a vital role in the construction and maintenance of this network. The light to medium traffic conditions experienced on the majority of these roads ideally lend itself to the construction of seals using bitumen emulsions. All indications are that bitumen emulsions will continue to play a vital role in the future in the maintenance of the South African road network. Thank you very much for your attention.